Hello everyone, now we will solve this problem where we have to prove that cos square theta by 2 minus 2 sin square theta minus cosec square theta is equals to p square by 2p square minus q square. Let's solve this. First of all, we will modify this equation. We can write sec theta as 1 by cos theta plus 1 by sin theta, that is equals to q. The LCM is sin theta cos theta. So cos theta plus sin theta is equals to q. Here sin theta plus cos theta is equals to p, so we can write p by sin theta cos theta equals to q, or p by q is equals to sin theta cos theta. If we take square both sides, we get p square by q square is equals to sin square theta cos square theta. Now we will take this equation and we are taking the LHS, means left hand side. So LHS cos square theta by, here we are taking 2 common, so we can write 2 into 1 minus sin square theta minus cosec square theta, we can write 1 by sin square theta cos square theta. From here we are taking the LCM, sin square theta. So 2 sin square theta into, we can take 1 as sin square theta plus cos square theta, then sin square theta minus sin square theta, it will cancel, we will get cos square theta. So we are writing cos square theta minus, this is 1. The sin square theta will multiply here, so cos square theta into sin square theta by 2 sin square theta cos square theta minus 1. We have already got the value of sin square theta into cos square theta, that is p square by q square. So we are writing p square by q square, p square by q square minus 1, p square by q square q square the LCM, so 2p square minus q square cancel, so p square by 2p square minus q square. This is equals to RHS. Proved. Thank you for watching.